average atomic mass, also known as atomic mass or atomic weight. Those are all synonyms. This is the weighted average mass of all atoms of an element measured in AMUs. For an element with isotopes A, B, and so on, could have more, the average atomic mass is simply the sum of the mass of one isotope times its percentage plus the mass of another isotope times its percentage, and so on. If you had titanium, for example, you would have mass A, mass B, C, and D, and E. You'd have to do this 5 times. Simply take those products, add them all up, and that's the average atomic mass. Those percentages are called the percent abundances, and it's most useful if you use the decimal form of a percentage. So, for example, if we know that the percentage of such and such an isotope is 25.3%, when we use this equation, we'll use 0.253. We'll move that decimal 2 places to the left for every percentage when we use it in the equation. Let's try a problem. Lithium has 2 isotopes. Lithium-6 atoms have a mass of 6.015 AMUs. Lithium-7 atoms have a mass 7.016 AMUs. Notice, lithium-6 atoms have a mass very close to 6, and lithium-7 atoms have a mass very close to 7. In any case, lithium-6 makes up 7.5% of all lithium atoms. Find the average atomic mass of lithium. So we're going to start with the equation. We're only going to have 2 isotopes, so on the right side of the equal sign we'll only use isotope A and B, for example. Isotope A, let's say, represents lithium-6, so the mass of a lithium-6 atom is right here, 6.015 AMUs, multiplied by the decimal form of the percent abundance, 0.075, plus the mass of the other isotope times its percent. We don't know the percent abundance of the other isotope. Actually, we do, because there are only 2 isotopes. If one of them is 7.5%, then the other one must be 92.5%. And now all we're going to do is we're going to multiply that out, and multiply that out, and add them. And we get this number, 6.94 AMUs. This is the average mass of a typical lithium atom. But realize that there are no lithium atoms, we believe, anywhere that have this mass. If you're a lithium atom, and very few of you are, but if you are a lithium atom, you either have a mass of 6.015 AMUs or you have a mass of 7.016 AMUs. No lithium atoms have this mass, but when we're dealing with lithium atoms, we're often dealing with them in very, very large numbers, and so their average mass is about 6.94 AMUs. Now, if we look up lithium on the periodic table, we'll notice that we actually see this number underneath lithium on the periodic table. So we could have actually just answered this question by looking at the periodic table, what's the average atomic mass of lithium? And we could have said 6.94 because it's right there on the periodic table. That number has 2 meanings. It's the molar mass in grams, and it's also the average atomic mass in AMUs. In other words, if you have Avogadro's number, 6.02 times 10 to the 23rd lithium atoms, some of them will be lithium-6, some of them will be lithium-7, but that many lithium atoms is going to have a mass of 6.94 grams. Your average lithium atom has a mass of 6.94 AMUs. So that decimal number on the periodic table has a double meaning. The table has been rigged so that it could refer to the mass of 1 mole of atoms, in which case the number's in grams, or 1 average atom of that element, in which case that number refers to AMUs. Let's try another problem. Here we have 3 isotopes of silicon. We're given the masses of 2 of them, and we're given the percent abundance of 2 of them, and we need to fill out the rest of the table. Well, filling out the percent abundance is quite easy because the sum of these 3 percentages must be 100%. But we don't know the mass of silicon-30. How are we going to find this? Well, if we start with the equation, notice that here we have 3 terms in the equation on the right side because we have 3 isotopes of silicon. And we know the mass of silicon-28 and its percent abundance. We know the mass of silicon-29 and its percent abundance. We don't know the mass of silicon-30, so I put X there, but we do know its percent abundance. Now, of course, we can't solve this because we have an empty spot here on the left side, and we don't know what the average atomic mass is. However, we just learned on the previous slide that the average atomic mass is actually printed on the periodic table, which means for silicon, the average atomic mass, according to my periodic table, is 28.086 AMUs. Now you can see that we have this equation. There's a single unknown, X, and this is just a matter of doing the algebra correctly and solving for X. So I'll go through those steps very quickly. I'm going to drop the left side of the equation down. I'm going to multiply this quantity, and I'm going to multiply this out, and I'll write those terms for you. Then we'll combine the 25.806 and the 1.353 to give us that. Now we're going to subtract 27.159 from both sides, and finally we're going to divide both sides by 0.031, which will give us what X is. X is the mass of silicon-30, and you can see it's very close to 30, 29.90.